We will be discussing about the Lambda function, okay, in depth, how Lambda function is internally working and how Java 8 is implementing Lambda function with the help of which it removes the long lines of code, right? So we will be learning all of this in this. Okay, so we'll be sharing the screen once. So basically, if you want to print something, then what you would have written? You would have written public void m1. Okay. Then within that, what you would have written? SOP. This is m1 method. Something, anything, you can print anything. Okay. So this thing will come under this method. So if we want to convert this to Lambda function, then how it will work? How you can convert this whole method signature as well as method body into a Lambda function. So you will just be shocked like how it is getting converted to just single line. It will be just memorizing. Okay, you will just get astonished how it is getting converted. So here, what is a Lambda function? Okay, so we in the past lecture, in the introduction lecture, we have learned what is Lambda function. It is a anonymous function. So why it is called as anonymous function? It's an anonymous function because it doesn't have any name. So if you convert this function to a Lambda function, you can remove this method name. You can remove this method return type. Return type is also not required. And there can be no access specifiers. Access specifier is also not required. Okay. Then if you remove all of this, then what is remaining? Only this bracket is remaining, right? So this bracket you can put up here. Okay. And then after that, what you can do, what is remaining? This bracket is remaining. You can put this bracket and you can write this print statement. Whatever you are printing, you can put it there, semicolon, and then you can close the bracket here. Okay. So like this, it will be there. It is already present in the existing method. We have just removed these three things. Okay. Because it's a Lambda function, it's an anonymous function. So we don't want method name, return type, and access specifier. These all things is not required in Lambda function. So you can see how much boilerplate codes is removed. So we are considering only one method. Let's suppose like this, there are hundreds of methods in a project. So how many variables, how many access specifier, how many method names, how many lines can be reduced? Okay. So here there will be only one thing which you have to add, which is this arrow mark. This arrow mark will tell you if this method refers to the elements present in the method body. Okay, so this is the method name. So you can, if you see anything like this, you can just imagine like it's something like public void a1, public void m1, public void m2, public void c, d, something. You can imagine like that it's a method signature. You can understand it like a method signature, and it refers to something which is present within that method. Okay, so it's a method declaration, and within this method signature there is a method body. So method signature or the method declaration refers to the method body present. So there should be a link between the two, right? So that linkage is been shown using the arrow mark. So if there is only one single line, then you can remove this curly braces as well. There is no requirement of using this curly braces if there is only one single line. So it will be still reduced to this thing. SOP, something you are printing like this. You can see in just one single line, this whole method gets reduced. This whole thing gets reduced to just one single line. Okay, so this is the major advantage of using Lambda function. Okay, so but we have to understand here in Lambda function to implement, there should be a functional interface. That also we have discussed in the introductory class, right? In the last lecture. So there should be a functional interface because Lambda function implements functional programming. That means it should implement a functional interface. And what is functional interface? Any interface which has one and only one abstract method. It can have any number of default and static methods which will be coming in interface. In Java 8 only default and static methods came, right? So it can have any number of default and static methods, but abstract methods should be only one. That is the most important thing. Okay. But this also interviewer may ask, like if I have n number of default and static methods and only one abstract method, will it be a functional interface? Yes, it will still be a functional interface. Okay. And there can be another scenario, like if I write @functional interface, can it be a functional interface? Yes, 100% it will be a functional interface with the help of @functional interface annotation. So here you will not be adding any abstract method explicitly. Okay. So compiler will tell you, hey, it is this interface you have mentioned it as functional interface. Why are you adding other methods? So compiler only will not allow you to add extra methods. Okay. So this is the advantage of adding annotation. Okay. So this is the things which we have been learning here. So now one more example I'll be taking. You can just note it down and we will be going with another example. Okay. So I hope you have taken down the notes for this. So we'll be going with one more example where I will be taking the sum of two numbers. How can you do the sum of two numbers? You can do with the help of method, right? Let's suppose you have created one main method, and in main method you have taken two numbers, a and b. You can take n number of numbers, but for making you understand, I am taking two numbers, a and b. A is having 6 and b is having some other number, let's suppose 8, and you are calling another method. Okay, so in Java, you know, right? The best practice is to create a method and call that method from the main method. That will become more as per standard. Okay, so if you create a method, how will you create a method for adding two numbers? You will write public. Let's suppose you want to return, okay, public int sum, and you are taking two arguments, int a comma int b. Okay, and within this, what you are doing, you are initializing a variable called sum. Okay, and you are doing sum equal to a plus b, and then you are returning the sum from here. Return sum. So this code you have written to get the sum of two numbers and returning it to the calling method, which is the main method here. So if I want to convert this method to a lambda function, to a lambda expression, how can you do that? Can you convert it into a lambda expression? How can you convert it into a lambda expression? You can convert it very simply. So we have learned, like in lambda expression, there should not be any method name. There should not be any method return type. There should not be any access specifier. Okay, these all things we can omit. So what is remaining? And when we are making use of functional interface, there we are passing the argument type, right? It's of int type. We are passing there. So this thing should be matched with the interface abstract method. Okay, to make use of lambda function, everything can be omitted. There is no issue. But the parameters which are present within this method, that should be mapped with the interface abstract method parameter. Then only lambda function will work. So in abstract method, which is present in the interface, there also it is expecting two numbers, int a and b. So here also it is present int a and int b. So compiler will understand it is implemented from the interface only. So the return type only also they will understand, like the return type of two numbers are int type. So it's not mandatory to write the return type here. We can omit the return type also. We can remove the return type here as well. So we can just write a comma b. Okay, then what we can do, if we just try to return it directly without creating the object. Otherwise, you can write it within this curly braces and you can write all those code. But we don't want to create the extra variable. Why we want to create extra variable? We can just return this sum of two numbers, right? So from here, we can do return a plus b. Like this we can do, right? Instead of sum, I'm writing this directly. Okay. So in between two, how can you map between these two? These two are separate entities, right? We have to map these two. How can you map? Just we have to add one lambda expression. With the help of this lambda expression, you can relate the method signature with the method definition. So this is the method signature part, which contains the parameter, and it is a method definition part or the body part, which contains the actual logic which you want to return it to the calling method. So you can do this with the help of three ways. Okay, you can reduce this big method to a small method, which is removing the boilerplate code using 3 ways. First way is with the help of anonymous inner class. With the help of anonymous inner class, we can reduce this code. Okay, so with the help of, we can call another method from the main method with the help of anonymous inner class. Okay, second way is with the help of lambda function. Third way is with the help of streams. Streams also will help you to reduce it to one single line, but we will be learning it in collection. After collection, we'll be learning. Okay. So as of now, we will be understanding these two things: anonymous inner class and lambda expression. Now, what is an anonymous inner class? Anonymous inner class is something like if you want to call or if you want to create a method within a method. So in normal Java program, is it possible to write a method within a method? Let's suppose there is a main method. Okay, there is a main method. In main method, you are writing some piece of code. Okay, and within that, you are creating one more method A, and then you are writing again some lines of code, and then you are closing. Is it possible in case of Java? Can you write a separate set of method with declaration and body within the main method or within any other method? No, right? You can at max call a method separately from the main method, or from one method you can call another method, but you can't create one separate method with method definition and declaration, everything within the existing method. It is not possible like this. Apart from calling any other method, you can't create a separate method within a method. Okay, so this is not possible in Java. So with the help of anonymous inner class, we can make use of a separate method within the method. That is a possible. Okay, so how it can be possible? So let's suppose there is an interface which contains this method, some method. Okay, and then there is a main method. So within this main method, what we can do, you can call this a method, or let's suppose you want to calculate a sum of two numbers. Okay, so that you can do with the help of this main method. Okay, so with the help of that interface, you can create the object of the interface. Okay, that interface object, if you create, and within that, if you override that method, then it will automatically show you a compile time error if you are creating the object of the interface. Then if you try to add the unimplemented methods, then automatically it will create an anonymous inner class. So let's suppose the interface name is some interface. So it will create an object like some interface. You can't create an object of any interface, right? But with the help of anonymous inner class, you can create the object, but we have to create an anonymous inner class. Then only you can create the object. Otherwise, it's not possible. So let's suppose you are creating the object of an interface. The some interface equal to some interface. And then within that, we have to override that one method. What is one method you have created? Some method. The some method you have to override here. There will be annotation @override here. Okay. And then we can call this some method. Everything will be written public void sum. And within that, we are doing return A plus B. Those things will be done within that. So what we are doing, we are basically writing a method within a method. Okay. So there is a main method before that. And within main method, you are writing all this code. Just focus on this part. So within main method, you are creating this interface object reference. And then within that, I'm creating one reference. So within that, you are overriding the sum method, which is present in the interface, and you are returning the sum of A plus B. That means this is the method. It's a method I have written within the main method. So that is possible with the help of anonymous inner class. So to make you summarize this, it's an inner class anonymous because the class I am not mentioning it any class name. Can you see any class name here? No, right? It's a kind of anonymous function. Okay, so this is an anonymous function. Some method you are writing this, but you are not writing any other type. What are the types? Okay, so this is like anonymous. There is no class you can see. Okay, there is no function return type you can see. So you can understand it like an anonymous thing, which doesn't have any name or it doesn't have any return type or any access specifier. Those all things can be written as anonymous. So here it will be anonymous class. So within the anonymous class, you can consider it like an anonymous function as well. So how can we convert this anonymous function to a Lambda function? Okay, so this anonymous, if you just clear all the drawings. So what we did here, we did the main method. Okay, and within main method, what we did that sum interface A equal to new sum interface. See, normally it's not possible to create an object of interface, but if we want to create an anonymous function within this, then we can go for creating the object. So after this, it will expect something. So we have to create a bracket here, and within the bracket here, whatever you are writing is the anonymous class, because within this there is no name, right? What class it is present. So these all things will come in a separate class. This whole thing will come in a separate class. So this class name you are not writing here. What is a class name? That means it's anonymous in our class. So within this, what we are doing, we will be overriding that method which is present in the interface. There is some interface present here, SUM, some interface present over here. Okay, this some interface contains a method, only one method present. That means it's a functional interface in A, int B I have written. Okay, now this is being used here. So within this, what we are doing, we are writing public void sum. Here we are passing A, B. Okay, it's int A, int B, and within that we are returning A plus B. And above that, we are overriding that method. So we will be writing here override. Got it? So this is the way we are writing the anonymous inner class. So if I want to convert it into a Lambda expression, how can you convert this anonymous inner class to a Lambda expression? So you can convert it very easily. Okay, so let me show you how. So if I want to convert it into a Lambda expression, how can you do it here? This is within this only you are writing this. So what we can do here, we can directly make use of this interface. Left hand side will be same. Left hand side will be same. Right hand side will be replaced with a Lambda function. So this thing is not required. Return type and all, the name and all is not required. So what you can do, you can take two parameters, because to calculate the sum you need two parameters, right? So what all things it is expecting? It is expecting two parameters. So I will be writing A, B. Okay, this A, B gives A plus B. That's it. Whatever thing you are returning, you are putting it here. Simple. Okay, and with the help of this reference, you can call the sum method. This sum method, you are calling it from interface reference. So you are calling the interface reference you are creating here, and from this reference variable, you are calling the method which is present within this. And what is the value present in the sum method? It's been calculated over here. The sum is A, B. What we are doing with A, B? You are doing the sum of two numbers. So this functional programming reduces this whole line of code into, this whole line of code gets converted into just one single line. And with the help of this reference, you are directly calling this method over here. Understanding? That's it. If you just print this A.sum, it will give you output. Okay, so let me go to the code and let me show you. So here, if you can see, it's a main method. Okay, and within this main method, okay, let me share my screen. I hope you can see my screen now. So here, if you can see, I am creating one Lambda interface here. Okay, so I have created one interface over here. It's a functional interface. See, we can put it like I did it functional interface over here. Okay, it will tell you that this contains this interface should contain exactly one abstract method. Okay, it should not contain more than one abstract method. And it's written after that. See, since default methods have an implementation, they are not abstract. Okay, so we can have n number of default and static methods in this, but abstract methods should be only one. That is the meaning of functional interface. So within this, what we are doing, we are creating the object of it. Okay, and within that, we are opening this flower braces. That means it's a method. It's a method present within this method. It's a main method. So within main method, I'm writing one more method. That means it's a method within a method. That is called as anonymous inner class. With the help of this anonymous inner class, we can create a method within a method. And we can call it as anonymous functions as well. Okay, because here we are not mentioning any function. What is the function within which you are writing all this? So this we can consider it as anonymous class only, anonymous inner class as of now. Within that, what we are writing, we are overriding that sum method present in that lambda interface, and we are returning a plus b. And whatever value is coming in the sum, we are calling the sum method and passing those values a comma b here. And with the help of this a comma b, we are calling the sum method, and it is getting added here, and we are reprinting the result. So with the help of lambda function, how can we do here? With the help of lambda function, what we can do, with these all things can be removed. If we remove all these things, what we can do, it will just expect two arguments, right? It will take two arguments, x comma y. Okay, and the help of x comma y, it will give x plus y. That's it. You can't take the same variable, right? A, B, you can't take here. It's like a local variable. You are taking a local variable to calculate a sum, right? So you can't take the same local variable here. You can't take the same local variable here. Lambda expression cannot redeclare another local variable. Okay, so it's already defined. So we have to take in a different local variable. So we are taking it here, x and y. So x comma y gives x plus y. That's it. In one single line, what you did, you have removed this 5 to 6 lines of code in just one single line. Okay, this is the magic which happens with the case of lambda function. And what we are doing at the end, we are with the help of this interface reference, we are calling the sum method, and we are passing this a comma b. So what it is internally happening, if once we are calling the sum method over this reference, a comma b, 4 comma 5 is passed over here, and x is assigned with the value of a, that is 4, y is being assigned with a value of b, that is 5, and here it is doing 4 plus 5, that is 9. It is returning the value result 9 to the sum, and we are getting the result here as 9, and it is returned to result, and we are printing this result over here. And if we just run the code, it will give you 9. Okay, so you see that the whole big chunk of code got reduced to just one single line. So what is the major advantage of using lambda function from this whole lecture, which we are learning from long time? The major advantage is lambda function is reduced. Oh, sorry, boilerplate code is reduced over here. So we are reducing the boilerplate code, right? So instead of 5 to 6 lines, only one line we have to write. So it will enhance the code reusability. The readability of the code is also getting enhanced, and boilerplate code is also getting removed, or redundant code also getting removed. So this is the major advantage which we are getting with the help of lambda function. So we all should be knowing how to implement lambda function, and we have to implement it wherever and whichever place possible in the project, because it will save your time only if you are using lambda function. Okay, so I hope you have got the understanding of the whole lambda function and how and all it is working. So in the next lecture, we'll be learning about functional interface, like what are the ways, like what scenarios we will consider it as a functional interface, and what all scenarios will not be considered. Those 3 scenarios I will be explaining, and after that, this whole concept will be covered till now. Then after collection, we will be teaching you certain more concepts linked with collection. Okay, so till the time collection is being taught, so these things, basic things, should be known to you. So that things I have told to you. So I hope you have got the basic idea what is lambda function, what is a functional interface, and how lambda function is implementing the functional interface, that is functional programming, how it is all working internally. Those all things I hope you have got some idea on it. So we'll be seeing the next lecture and I will be explaining you those 3 types of functional interface where the data will be able to get the data, and there will be, like, with the help of inheritance, I will be telling you if one class is implementing that interface, or sorry, one interface is extending that functional interface, then what will happen if it has one abstract method, or if it has more than one abstract method, then how will it behave? So that I will be showing you in the next lecture. Okay, till then, stay tuned and practice all this code. Bye.